Ladies and gentlemen, hello and welcome back once again to the Inside Analysis Big Data Ecosystem Market Overview. My name is Eric Cavanaugh. I'll be your moderator for today's presentation. Folks, we're very excited to be talking to RedPoint Global. Some good friends of ours, George Correjo is on the line and Louis Clemens from RedPoint, and they have a really interesting solution that focuses on, you guessed it, big data. So they play a significant role in the big data ecosystem, and today we're going to find out exactly what that is and what they do. And with that, I'm going to hand it over to you. George Correjo, the floor is yours.
Thank you, Eric. Thank you for having us today, and I appreciate the opportunity. So what I want to do is just highlight a few of the points that we're going to talk about today and give you a kind of a perspective on how we fit into the Hadoop ecosystem. First of all, RedPoint Data Management is our broad-based ETL, data quality, master key management, and data processing automation platform. What really distinguishes it from the other tools in the Hadoop and big data ecosystem is its breadth and maturity. And we see that in its validated ease of use, speed, match quality, and customer data superiority. We've actually been ranked #1 in Gartner customer satisfaction surveys for match quality, for speed, for ease of use, and customer or party data. Now, what we've been able to do through our integration with Hadoop 2 and Yarn, we've been able to bring that breadth of data quality, functionality, ETL, et cetera, and that speed, the optimization that we've developed over the years, the quality of our matching, and our ease of use, and bring that all directly into the Hadoop ecosystem. And we were able to do that through a Yarn integration, and actually we were one of the first 17 companies that were Yarn certified back in October of last year, so I'd like to say that we're one of the oldest pure Yarn applications on the market. And what's interesting about that is that there's a lot of companies out there that are Yarn certified, that are part of the Hadoop ecosystem, but in fact what they've done is they've taken a lot of their Hadoop 1 functionality and just repackaged it. We skipped Hadoop 1 altogether and went straight for the direct integration and porting of our binaries, our optimized code, our optimized processing, and we push it directly into the HDFS for processing. So we bring all that broad functionality, that ease of use, and where we really have an impact is on the...
Hey, George, hold on. For some reason, your audio is really breaking up bad. I just got a text from Rebecca, so it's not just me.
Oh, okay.
Can you hear that?
Yeah. Well, Carol, funny you say that, because Carol just jumped in here and gave me a note that it was breaking up. So let me.
Is it? So is that? Do you know? Is that a VoIP? Is that like in your office?
Yeah. How does this sound? Is this better?
Oh, much better.
Much clearer.
Yeah.
Much clearer. Okay.
What did you change?
I had my Bluetooth earpiece in, but this is the handset. Yeah. Sorry about that.
No worries. No worries. So I'll tell you what. What I'll do is I think I can, you know what we can do is just go back on the slide, because the way the WebEx recordings work is you can set the start time, so you can cut off a big chunk up front, and we can just start over. So just pretend that we didn't do any of that stuff. I'll do the whole introduction again, and we'll go from there.
Okay, great.
All right, sorry about that. I was like, I mean, the problem with these audio issues is like there are 18 different things that could be going wrong, and you're like, all right, is it this? Is it this phone? Is it that phone? What's going on? And then you're talking, I'm like, okay, am I losing my mind? All right, so hold on. My apologies, but we want to make sure you get a nice, crisp sound for the recording.
Yeah, great. No, and sorry about that.
No worries. Okay, all right, stand by. I'm going to do it again. Hold on. I'll start at 4:20 on the recording. Here we go. Ladies and gentlemen, this is Eric Cavanaugh talking to you once again, and welcome to the Inside Analysis Big Data Ecosystem Market Overview. That's right, folks. We're talking to a lot of different companies here in the big data space to better understand where they fit, what they do, how their particular solution might be of value to you. And today, folks, I'm very excited to be talking to RedPoint Global. I have to say this is one of the most compelling solutions we've come across in a while, and as many of you know, we work with 80 or 90 of the most cutting-edge vendors in the industry. So these guys are really onto something very interesting. We're very excited to have them on board today. We're going to be hearing from George Correjedo and from Louis Clemens about what they do. So with that, I'm going to hand it over to George. The floor is yours. Show us what you got.
Great, Eric. Thank you very much, and thank you for having us on the show here. So what I want to do is just cover some quick points about the application and what we bring to the Hadoop ecosystem, and then we'll show you the application itself and do a quick demo for you. But the first thing I want to point out is that we are a very broad and mature application, and in an ecosystem where you have a lot of immature applications that are very narrow and very niched, we really stand out as a very broad platform of ETL, data quality, master key management, and broad data processing automation. We're an application that's been in the market for a long time and bring a lot of functionality into this Hadoop ecosystem. In fact, Gartner has us ranked #1 in terms of ease of use, speed of processing, match quality, and customer or party data. And what that tells us is that, we have an application that was already validated in terms of its robustness, its functionality, its ease of use, and we've been able to bring all of that directly into the Hadoop ecosystem through our Yarn integration into Hadoop 2.0. In fact, we were one of the first 17 companies to actually be certified in Yarn, so we like to say that we're one of the oldest Yarn applications out there on the market. So, but what that allowed us to do is skip over the whole wave of Hadoop technologies or Hadoop-oriented technologies that were still dealing with MapReduce as an intermediary and go directly from our code, our optimized code, and push it directly into HDFS for processing. And there's lots of impacts of that, and we'd love to talk some more about that at some point, but it really brings a tremendous level of performance and ease of use to the environment. So we're really excited about that. The beauty of it, and where we really have a huge impact, is on user productivity. You're able to build very complex jobs in RedPoint data management at a fraction of the time that it would otherwise in any other competing tool, or certainly in any kind of code-based solution. It's all a very intuitive data flow paradigm, and you don't have to touch a line of code. In addition, we are also very good cluster citizens, if you will. And what I mean by that is that there's lots of applications that claim to be working in the cluster, and they have all sorts of issues in terms of how they steal the resources in your cluster, that you have to actually install the application in all of the nodes in your cluster, and often you install it in the cluster, it pulls data out, processes it, and then pushes it back into HDFS. And we don't do any of that. We're very, very efficient in our use of resources, in our footprint, and we leave the cluster absolutely pristine after we've run our processing. All of our processing runs natively inside of HDFS. So there's just a great deal of efficiency that we bring to it. And we bring a functional set that is very, I think, important in the world of Hadoop. A lot of the data that ends up in Hadoop is the type of data that actually came from outside of the organization. It might have come from devices or social networks or whatever. And it's really important to have very robust data quality and other types of governance capabilities so that you are sure that you're dealing with very clean data when you're trying to build your analytics and your predictive modeling and so on. So we bring a very essential functional footprint. And just to dive into that a little bit, as I mentioned before, ETL, ELT, very robust, very broad sets of functionality, transformations, access to any sort of data, any format, any structure, lack of structure, any cadence. Our motto is no excuse for not capturing data anywhere it exists or gets generated. As I mentioned before, robust data quality, data cleansing, parsing, global address standardization, geospatial analysis, geocoding of the data, integration and matching. We think that part of making data useful is being able to link data sources together across different sources and bringing entities together so that if you have George Corredo who appears in the physical domain of data in Wayland, Massachusetts, and then GRC27 in Twitter and G27C in Yahoo, all of those are the same person. And linking those together allows me to be able to understand how that person is behaving across channels, across contact points. Similarly, if it's a device, if it's a vehicle, the ability to link those entities together is really important. And then keeping those keys over time allows you to see how those entities behave over time. Web services integration and lots of processes automation is what you'll see in the application. And Lewis will show you more of this in the demo. But how the impact, and I just want to make sure that I give you this visual, the impact of all of that broad functionality in the Hadoop ecosystem is simplification. What we're able to do is to bring where you would normally have lots of disparate applications trying to do very narrow bits of functionality across the ecosystem. You can have RedPoint across that ecosystem, and in fact across your structured and non-structured databases, and have one application that serves all your databases, whether there be the traditional RDBMSs, whether it's Hadoop. You have one interface to operate across all of them. And in fact, because we are a zero footprint install and install outside of the cluster, you can actually have one installation that can simultaneously work across Oracle or Teradata or Microsoft SQL Server and Hadoop. In fact, Hadoop now becomes a scaling platform, and it really becomes like a non-issue. And so what we've really tried to do is find a way of mainstreaming the power and the efficiency and the flexibility Hadoop brings, and do it in a way that we can take a DBA, train them in a week, and they're working on Hadoop just like they're working on Oracle. Last slide, and what I want to do here is just show you the impact of in terms of productivity. And this is just kind of a classic problem that you get with Hadoop distributions, Project Gutenberg. It's a word count problem, and what we did is, taking it out of the box, we had to optimize the code. You're writing MapReduce code, and it took about 6 hours of development, and we got it to run in 6 minutes in a very small, what we call the Best Buy developer discarded desktops cluster that we've built. And it took about 6 minutes to run once we built the 150 lines of code. In Pig, a somewhat abstracted language, it took us 50 lines of code. We did have to write a UDF, and it ran in about 15 minutes. And here's the striking difference. In our application, not a single line of code was built or generated, and that's really important, pure yarn. Not a single line of code was built or generated. We developed it in 15 minutes, and it ran in 3. So not only was the processing time less, but the development time was dramatically less. So with that, I'm going to stop here, and I'm going to turn this over to Louis Clemens, who's now going to walk you through the actual application.
And what we're looking at, and I'm hoping everyone can see my screen, what we're looking at is the environment for developers in RedPoint data management. And specifically, what we've got is a pretty typical drag and drop environment where you have about 100 different capabilities represented by icons, and these define the various data input types. They define the sort of standard ETL functions, and then extensive support for various types of data transformations, for hygiene and quality, and for various types of parsing and record matching. Those icons get dragged into a working environment, or out of the palette into a working environment, and then configured on a tool-by-tool basis. The jobs themselves can be anything from fairly simple projects like this demonstration project for bringing two files that have no overlapping keys together by name and address, to complex sets of multiple sources and multiple transformations, both in the standard operational environment and in the Hadoop ecosystem. The only difference between the job that you see here and a job on Hadoop is this, and that's the notion of putting part of the job inside a Hadoop wrapper, and this tells data management to partition the data or across the cluster, and then to run those data inside the cluster as a scalable computational architecture. Now, how do we do this is one of the questions I get frequently asked, and George talked about the notion that we are a pure yarn application. And what we mean by pure yarn is we don't generate any code. Instead, what we do is let data management know where the cluster is, where the Hadoop environment is, where its working environment is, and then we copy a full production version of our application into tarballs and distribute those tarballs on HDFS. When we run a job, those tarballs are then distributed out to the nodes that we are working with, and those nodes are assigned by the resource manager in Yarn. And our application is running under the control of the resource manager in Yarn, effectively using it as an operating system. Anyway, our application is pushed out to the nodes and then begins to run on that node, and the instructions to distribute data and the instructions on what to do with those data are then passed to the application. What this in fact allows us to do is to run jobs that are entirely within Hadoop, that are entirely on the traditional operational side, or to blend across the two environments seamlessly. So now some specific details on what we do and how we do it. So George had mentioned the notion that we can work with just about any type of data, and that's everything from various delimited file types and flat file types and COBOL copybooks to just about any database that's out there. We can also work with complex or variant data types, and this would include the various electronic data interchanges or other data sources. And we can then bring those into Hadoop in a number of different ways. We can copy them in as live streams of data. We can copy the files into the Hadoop environment. So a bunch of different ways of getting data from your outside Hadoop ecosystem into the Hadoop environment to do work. Once in Hadoop, we have 100% of the functionality of data management inside the cluster. And again, that's because we're essentially running a full copy of our application inside the cluster. But as George noted, it's a zero footprint environment, which is to say you don't have to do any installation, you don't have to worry about resource management. That's all being managed by the cluster as part of our Hadoop citizenship approach. In terms of the types of functions, we talked about the different types of data that can be read in. There are about 110 different functions on the palette, and those range from address quality, name parsing and matching, very complex and robust fuzzy matching and record management, a complete parsing library that's built around a POSIX regular expression set, and a extensive capability to do data manipulation. A lot of that data manipulation is driven by our is driven by our expression language and the types of transformations that we support. And those functions range from binary decomposition of data to the full set of date and date time transformations, to being able to encode and decode URLs and be able to work with data coming in off of web services, to a broad set of geospatial transformations, and of course textual transformations. So all of this becomes available in an environment that is got a much shorter learning time and is far more optimized than is code generation in MapReduce or in one of the Pig or Hive abstraction environments. So what does this give us in terms of functionality and productivity? To look at an example, and this is the example that we looked at earlier where I have run the job, and on the operational server side, we have about 200,000 records coming in from a database table, and we've got about 3 million records coming in from a file. And these represent sales records and prospects in a marketing environment. They have no overlapping keys. We've address standardized the data. We've matched the data, and the matching is based on deep fuzzy techniques. And we've written the data out to databases. And this is entirely on the server side, and it ran in about 3 minutes, as you can see. The same job running in the Hadoop environment, where we read the database out externally to Hadoop, we mapped the data in, and this time we're going to map it against a 30 million record data set, and we're going to partition the data out by zip code for matching. The same match job, exactly the same logic, against 30 million records, though, in just under 10 minutes. So about 3 times the performance in this case on a fairly small cluster. Other considerations are the ability to manage the jobs and manage the environment, and we do this by providing an extensive set of console tools that allow you as the user to see what jobs are running in the environment at any given time, and for a job that's running to be able to look at its current state. There's an extensive logging environment that allows you to go through and see the history of all jobs that are being run, and to see those jobs at a very detailed level, including being able to get access to the yarn logs for detailed diagnosis on your jobs and your history. In addition, we have a version-controlled repository that allows you to create a folder metaphor, and within the jobs to maintain your history, and from that history be able to not just look at the job itself, but who checked the jobs in, and to be able to open prior versions to reuse code or to reuse flows and to fork the environment. The notion now is that all of this capability, this long-standing capability in ETL, in data hygiene, in data quality, in matching, in key management, in web services management, it all becomes available in the Hadoop environment at the application level rather than at the coder or code level.
So, Louis, you want to talk a bit about the automation layer and how that helps with the the overall processing?
Absolutely, George. In addition to being able to do jobs that are focused at the data task level, we also have an orchestration layer, and that's provided by our automation tool set. And the automations allow you to not just create jobs that are built out of other sets of jobs, and I'll drag a few in. And these can be wired up on both success and failure conditions. The green for a success condition, the red for a failure condition. It also gives us a palette of tools that allow us to control when jobs start, and those jobs can be started on the basis of calendar events, on specific intervals, or on daily, weekly, monthly, or specific day of week, month. We can start jobs on the basis of file patterns, whether on the server side, on the Hadoop side, or both. We can start jobs based on various database events, or so forth. We can also wrap in external applications, and these will allow us to call not just applications, but also allow us to wrap things like command line versions of MapReduce or Pig or Hive or other sets of code that allow you to bring your already existing Hadoop or big data applications into managed flows or into orchestration, the orchestration layer.
That's great, Louis. Louis, you also, we make a big deal out of the interface and the visual interface, but we've got other methods of actually accessing the tool through command line and XML. Could you talk a little bit about those?
Yeah, there's an extensive support for using data management in the context of a larger IT environment. We can be accessed through a command line, and at the command line, you can not only specify the job to run, but you can store values into the different tools inside jobs, effectively dynamically reconfiguring the job at runtime. So you can change the files that are being read, or the database location, or the values in a filter or a transform, all of which allows you to control not just the job that's being executed, but the terms under which the job is executed. We also have a web interface that allows you to come in as a user and invoke our application as a service, and there are a couple of different models of this. One of them is to simply call us as a service and allow it to run. The other is by using our ability to capture XML and JSON data as inputs and outputs to publish data management jobs as services that are listening on a port, are publishing a WSDL, and are acting as a service in your larger service orchestration environment.
Yeah, yeah.
Oh, go ahead.
Oh, I was just going to say, and the other thing is that the jobs themselves can be generated as XML files. So we actually have other applications within our RedPoint suite that will generate the XML that represents a job and then runs directly against the execution server. So there's lots of ways of getting to the functionality. We just think that the visual or graphical interface is just a very quick way, and again, really leads to developer productivity.
Yeah, right. In other words, you're really catering to a whole variety of potential end users. I mean, obviously, you're not going to have a business user who's completely non-technical getting in here, but the point is that you're really catering to the spectrum of developers who are used to traditional ETL type products, all the way through to power users who can use command line. And if I understand it correctly, what you've done is essentially provided an orchestration environment that allows companies to either A, leverage purely Hadoop-style jobs, or B, use this technology to bridge existing enterprise applications with some kind of a Hadoop component to essentially supercharge a particular solution, right?
Well, that's exactly right, Eric. Yeah, and the whole idea, you know, the way we develop all our applications is for this idea of openness and interconnectivity, because at the end of the day, applications don't stand alone. And if you want to go mainstream and you want to go enterprise, you've got to be able to work in those complex environments. So we've got lots of ways of accommodating that, and very much has been part of the development philosophy is to be able to do exactly that.
Yeah, and I love the amount of visibility you get into what is actually happening because, and maybe I'll throw this over to you, Louis, you know, troubleshooting is always one of the hardest parts when you start dealing with these really complex applications, and it seems to me that the amount of visibility you're giving into what's happening is a pretty strong selling point for this solution being very useful for all kinds of organizations, but specifically for people who really want to get stuff done and need to get stuff done and don't have a lot of time to waste, right?
Yeah, that visibility happens at a lot of different levels. So I'm going to go ahead and start this job running again, and we'll look at the most obvious level is, of course, showing you where you are in the flow and what tasks are happening. But we'll also show you the where you are in terms of process in the Hadoop environment. We'll also let you drill into running jobs. Let me scroll in here a bit and up, and you can see what resources are being used on any given job. In addition, if we look into the management tool, we can see the jobs that are currently running. And for instance, you would have just seen a whole series of partition jobs, but as my running job gets into the transforms, it will generate a whole series of jobs in the management environment. These are the actual tasks that are running in the cluster on a thread-by-thread basis. And I can view not just what's happening externally to the Hadoop environment, I can drill in and see what's happening within the cluster itself. So this is one of the jobs running on one of the threads. And again, I can drill in and see the resources that are being used by tool, by thread within the Hadoop environment. So I have a great deal of information as a job designer and executor to see what tasks are being run, and that's happening in addition to the logging and details that are being created. And as these jobs begin to complete, let's go here. As these jobs begin to complete, what we'll start to see is our completion of the tasks, and we'll start to see our percentage complete and where the job is in terms of its cycle.
Yeah, and that's really useful to anyone who is trying to make use of these tools because you get a better understanding for where things go wrong, which parts of the process are heftier than others, so to speak. But goodness gracious, I mean, a job this size, just cranking through in real time here, I mean, that in and of itself is pretty impressive stuff.
Right, and we'll give you some other things that are useful to understand as well. For instance, as I mentioned earlier, we will give you the full yarn logs in terms of what the job is doing. We also are very careful and cognizant about how data move about in the Hadoop environment, which is to say across HDFS. You'll notice that as part of the task that's coming in, we did a partition, which is roughly the equivalent to the mapping and the data distribution task in a MapReduce job. Every time we do that, we do a statistical sampling of the data, and we do a analysis and statistics-based partitioning that is aware both of where the data are and what the resources that are available are. This lets us minimize data movement and minimize skew on a job-by-job basis.
Yeah, data is not a small thing because it's all going across the network, right? Anytime you're using different nodes, you've got stuff running around the network, right?
Absolutely. So we're trying to minimize and flatten the data distribution across the network so we don't end up with hotspots or with laggard nodes because of data skew.
Laggard nodes, I love it. Well, hey, George, did you have a last couple of comments you want to make?
Well, I just wanted to, hopefully you've seen and can recognize that what we've tried to do is address kind of both folks trying to get into the Hadoop environment and start leveraging Hadoop, and we really try hard to make that easy for them, make that jump easy. We can take their existing skilled resources, train them up, and then they can be off and running on Hadoop with really very little effort, as well as addressing the other end of the market where you've got real savvy Hadoop cluster managers and are worried about things like skew and load and laggard nodes and whatnot. And so we really, and I think we achieve that, that breadth. And I think that's what comes with a very robust and mature application. So we're real excited to be in this market. We think we can add a lot of value, and hopefully we get a chance to talk to folks about it some more.
Yes, indeed. Well, folks, we've been talking to RedPoint Global, George Corrado and Louis Clemens, and I got to say, this is really cool stuff, guys. You've done a fantastic job, and I'm sure we're going to be hearing a lot more from you in the future. So thanks so much for your time.
Thank you.
Thank you.
Okay, folks, this concludes one more of our recordings for the Inside Analysis Big Data Ecosystem Market Overview. We'll catch up to you next time, folks. Take care. Bye-bye.